Hey everyone, welcome back to another calculus video. Today we're going to begin talking about how the derivatives relate to the behavior of a graph. Now, we've already kind of discussed in some of our videos in the previous unit how the derivative describes the slope of a curve. And so when that derivative is positive, that happens because my curve is increasing. And when the curve decreases, we talk about how that derivative turns to a negative value because the slopes of the tangent lines where my graph is decreasing become negative. But now we're going to take that a step further, and we're going to develop a couple of rules where we can describe the behavior of any function using information that we have about the first derivative, whether it's positive, negative, whether it's equal to 0. But now we're going to extend it, and we're also going to glean some information from the second derivative. So I always like to start this out with an activity. This unit where we get into this, I start with an activity that looks like this, and I ask my students to draw the first and second derivative of the curve using the points A, B, C, and D. And so what I'm going to ask you to do is if you have this worksheet, I want you to pause the video and I want you to make sure you filled in as much as you can. If not, take a moment, pause the video, copy the worksheet down onto your own paper, see if you can fill in some of these blanks, see if you can make the sketch, and then we'll take it from there. So hopefully your paper, as you sketch this and graph this, as you draw the first derivative, it should look a little something like this. Now, a couple of key points here where I have horizontal tangents on my original function, so that's going to be here at point A. I should have at my first derivative a 0 there. Same thing should happen at point C because this is where my function has these horizontal tangents. So I'm going to put those zeros in for my derivative. Now, where my function is increasing, I'm going to have a positive first derivative. So everywhere from up to point A, I should have a positive derivative. And notice the slopes are decreasing, so they're approaching 0. So my first derivative should come down kind of like this. It should hit A, and then everywhere in between points A and C, I'm going to have a negative first derivative because the graph there is decreasing. So I'm going to kind of come down. I'll dip down a little bit. Here at B, we kind of have this spot where my derivatives they look like they want to get steeper, and then all of a sudden they get less steep as you look. So they kind of reach this maximum steepness, negative steepness, I should say, and then they come back up and they have to hit 0 at that point C because that's where I have a horizontal tangent. Now, after point C and forever onward, my function is increasing. So I'm going to have positive derivatives. So the graph of the derivative here kind of looks like it's a parabola. Interesting. So now when we go to draw the second derivative, remember the second derivative is just the derivative of the first derivative. So what I'm going to do is I'm going to look and see where do I have horizontal tangents on my first derivative. And right here at point B, I have a horizontal tangent. So on the graph of the derivative, so remember the second derivative is just the derivative of the first derivative. So it's all derivatives, right? Same process. So at B, I'm going to have a 0. And then I'm going to look and see where am I increasing or decreasing. So up until point B, this graph is decreasing. So I'm going to have a negative second derivative all along here because I'm decreasing. So I'm going to be in the negative territory. So it might look something like this. It hits 0. And then all along here, I'm going to have a positive f double prime, a second derivative, because the first derivative is increasing. And so my second derivative will look a little something like this. So one thing that I want you to remember is that the second derivative is just another derivative. The function it's the derivative of happens to be the first derivative of the original function. So it can be a little confusing understanding what's happening. But the relationship between the first and second graph here is the same as the relationship between the second and the third graph. They're just derivatives of each other. So when we go to fill in our blanks, when a function is increasing, its first derivative is always going to be positive. When a function is decreasing, its first derivative is negative. Now, let's take it a step further. When a function is concave up, now we want to talk about concavity and what that means. So when I say concave up, I'm talking about where my function is kind of shaped like this upward facing cup. So here I'm concave up everywhere from B onward. So when I look at this, it's when a function is concave up, its first derivative graph is doing what? So from B onward, what's happening here? Well, my first derivative is increasing. So I'm going to fill that in. And then what's happening with the second derivative graph from B onward? The second derivative is positive. Which should make sense, because if the first derivative is increasing, the graph of its derivative, the second derivative, is positive. So that should make sense. So now let's look and see what's happening when we're concave down. So when I'm concave down on this graph, that's happening everywhere in this highlighted green region. So everywhere up to point B. Well, in my first derivative, everywhere up to point B, the first derivative is decreasing. So I'm going to fill that in. And then what's happening with the second derivative? Well, the second derivative is negative. So I'm going to fill that in. Now, let's keep going. When a function has a local maximum, the first derivative will be blank, and the second derivative is blank. So let's identify where we have a local maximum. Clearly at point A, we have a local maximum. So here at point A. So what's happening at point A here on the graph? Well, on the first derivative, clearly we have a 0. So I'm going to go ahead and fill that in. The first derivative will be 0. And let's see what's happening. What else is happening? When the local max, the first derivative will be 0. And now there's a second blank that we're going to fill in here. We'll come right back to this in just a moment. Let's look at the second derivative right here. But the second derivative at point A, the second derivative is going to be negative. Now, what goes into that other blank? Well, let's talk about what's happening at my local max. There's a couple things that I need to realize here. In my first derivative, in order to be a maximum, I have to have something else happening on my graph. And before we identify what that specifically is, let's take a look at the local minimum and see what's happening there. And then maybe we can draw some conclusions about what goes in that second blank. Now, let's see, what color should I use for my minimum? Let's use orange. So here I have a local minimum at point C. Okay, so at point C, okay, here's what's happening at point C. My first derivative is 0. Okay, so I'm going to go ahead and fill that in. Let's use an orange pen just to keep it consistent. 0. And then my second derivative is positive. Okay. And that should make sense, right? Because if the second derivative is negative, that means I'm concave down. So of course, that spot that's up here is going to be a maximum value based on the shape of the graph. Now, if the second derivative is positive, that means I'm concave up. So the shape of the graph means that that point that I know is some sort of special value. It's got to be either a max or a min. If the second derivative is positive, I know the shape of the graph is concave up. Therefore, it has to be a minimum value. So when we justify that we have a max or a min, it's not enough to say that the first derivative is 0, because check it out. It's 0 at both maxes and minimum, at maxes and mins. What you have to do is you have to give a second piece of information. And one second piece of information that you can give is you can talk about the second derivative if you know about it. If you know that the second derivative at that spot, at point A or at point C, is either negative or positive, then you can clearly say, well, the first derivative is 0, the second derivative is negative, therefore my graph has this shape, it must be a maximum, or my second derivative is positive, it must be a minimum. You can't, it's not enough to talk about concavity, you have to say why it's concave up or down. So when we start giving evidence, the two pieces of evidence that you're going to start giving are either you're going to say the first derivative is 0 and the second derivative is either positive or negative. Therefore, we have a maximum or a minimum. Now, the second piece of information you can give, you don't always have the second derivative to look at. The second piece of information you can give is to talk about what's happening with the first derivative. Now, the first derivative, when I had that maximum, so that's point A, right? So point A was a max. The first derivative was decreasing, right? So let's talk about this. If my first derivative is decreasing, then it changes sign, and this is the part you want to look at, from positive to negative. So if it's decreasing, we're going to see a sign change. So you need to talk about the fact that your function changes sign. That's the critical piece of info here that we need to focus on, that sign change. So we change signs specifically from positive to negative. So remember, your maximum, to hit a maximum, your slopes have to go positive, positive, positive. Here's your max, negative, negative, negative. So we're always going to have a sign change from positive to negative on that first derivative. If it's a minimum, you'll see the opposite. You'll see it go from negative, negative, negative up to positive, positive, positive. So for my minimum value, the first derivative is increasing. Specifically, we see a sign change from negative to positive. And that's what we want to focus on. That bit of information is what your AP graders are going to be looking for when they look for that evidence. So anytime you tell me that somewhere you have a max or a min, you need to tell me 2 reasons why. First reason is always that the first derivative is 0. The second reason depends on what other information is given. If you have info about the first derivative, you can say that, oh, we changed sign from positive to negative, therefore I have a maximum. Or you can say we changed sign from negative to positive, therefore I have a minimum. You can also, if you have information about the second derivative, talk about the sign of the second derivative being negative or positive. So it really depends on what the problem gives you. But no matter what, you'll always be able to find 2 pieces of information, and you always need to give 2 reasons why there's a max or a min. Otherwise, if you just say the derivative is 0, it could be a max or a min. The way that you decide which one it is using that other piece of information. So hopefully this has been a helpful little activity for you. I always have everybody in my class use this, and we use this throughout. So having this handy is going to be a really big deal. It's going to be a helpful tool as you study and as you're learning and as we move forward and start to do the math that goes along with looking at some functions. So keep at it. Make sure you copy this down, jot it down into your notes. It's a great tool to have as we move forward. And always remember, you can do this. It's going to be fine. You've got this.